Today, once again, for today's lesson, we're going to continue on with our algebraic skills and move into the actual first solving portion, okay? This is the first lesson where we actually have to go out and solve for one of our equations. Today's lesson will be lesson 1-3, which is a two-part lesson. Today we'll be talking about the first part, which is solving an absolute value equation, okay? Today's learning targets will be, simply put, students will solve absolute value equations, as well as students will use real-world examples to solve absolute value equations, okay? So you can kind of see that today's learning targets are right in line with what we have been trying to do. Main focus for today is going to be absolute value. Okay, so let's go ahead and just get into it. The first thing we have to talk about for today is, simply put, what is an absolute value, okay? The key thing you're going to have to understand is that absolute value is a symbol in math that helps describe distance. Okay, and I have this little blurb down here for us. Let me move my face out of the way. Absolute value describes distance from x to 0. Okay, if you have noticed that, I have that written right here. Okay, distance from x to 0. All right, that is a key term in math. All right, the next key thing is you understand that distance cannot equal a negative number. Okay, I can't move -5 meters. It just doesn't work in the real world. So what this value is doing is actually stating that this is the distance from x to where we originally started, which is typically 0 if we're using a number line in that fact. So with that being said, let's just kind of talk about what an absolute value is. If we look up at the little math tip here, okay, sitting right up here, they actually recall that a geometric interpretation of the absolute value of x is the distance from number x to 0 on a number line, okay? If you notice, the absolute value is denoted with those two lines in between a value, okay? In this case, they have an x. So that's how we actually show an absolute value. Last but not least, if you look down here, you can actually see what an absolute value is going to do to your values in that problem. In this case, if you notice the absolute value of x equals 5, then you're basically stating that x can equal -5 or +5, okay? The reason is because it doesn't matter if it's a negative or positive value, because we're describing distance, it's always going to make it a positive value, okay? So the idea of absolute value is that it's going to state a distance. The easy way to remember it is that absolute value will always come out as a positive value. So the idea would be if I had the, let me draw a line to block this off. If I had the absolute value of -2, that's just going to equal +2. Okay? If I have the absolute value of a +2, it's going to equal +2. Okay? The mathematical interpretation of it is it's a distance from x to 0. Okay? How far are you away from your original point, which is typically 0? The easy way to remember it is that it just is a positive number. It will always become a positive value. Okay? But for today's lesson, we're actually going to be solving equations like you see here, okay? Where we actually are given an absolute value and we want to know what does x equal to make that true. With that being said, I have a couple of steps here built for you, both 1, 2, 3, and 4. In step 1, we're going to get the absolute value by itself. Step 2, we're going to split into positive and negative. Step 3, we're going to solve for each, and then step 4, we're just going to check our answers, okay? An important step at the end of all of this. So with that being said, let's kind of get into it and let me help you describe these steps while doing a problem itself, okay? So we're going to start with letter B in your books, okay? Oh, sorry about this too. If you're looking for the page number, I believe it's page, sorry about that, completely forgot. This comes out to be page 11 in your books, okay? So let's go ahead and talk about letter B. The first step in all of these is I have to get the absolute value by itself. That means this little piece right here, the one that's in between the black lines, the x plus 1, everything that's inside the absolute value, I need to get it by itself on that side, the equal side, okay? That means this -4 I have to get rid of. And the only way I can do this is if I move it to the other side. So I got to somehow move this 4 over here. This is where we got to start pulling back our algebraic skills. We got to think, okay, if I have a -4, how am I going to move it to the other side? Well, you're going to hear me say it a lot this year, and I'll always reiterate it. If you want to move something over, do the opposite operation in what you're given. In this case, if I am subtracting 4, the opposite would be to add 4 to the other side. Okay? The reason is if I had a -4 and I added 4 to it, that's going to cancel each other out. And then on this side, if I work this out, I'm left with just a +2. Or in this case, I have the absolute value of x plus 1 equals 2. Okay? So step 1 done. Next, I got to move on to step 2. Now, step 2 is where the actual new process comes into play, the probably new thing that you haven't seen yet. Whenever I want to solve an absolute value, I automatically need to assume that in the original problem, I had both a negative and a positive answer. Okay, kind of like how we talked about up above. If I had the absolute value of x equals 5, it could be -5 or +5. It works out both ways. So what I have to do is I have to split it into 2 answers. Okay, the first answer is going to be x plus 1 equals 2. Basically the exact way you just saw the equation. The second piece is going to be x plus 1 equals -2. Okay? So see, I really didn't change anything with the absolute value. The only thing I really changed was a +2 and a -2. From there, I move on to step 3, which is just solve for each. I'm going to just subtract 1 from each side. This would be x equals 1. 2 minus 1 is just 1. And then same thing, I have to subtract 1 to each side. X equals, and then once again, bring back our algebraic skills. If I have a -2 and I'm subtracting 1, I'm moving backwards even more, okay? It's like saying you owed $2 and now you owe another $1. That's going to be -3, okay? Now, from this point, technically I have my 2 answers, okay? But in some cases, and let me just give myself a little bit more room here. In some cases, that actually tends to be an issue. Like you do need to check. Okay, let me clean this up a little bit. Sometimes you need to check and just make sure that those work, okay? You'll see sometimes it does work, and sometimes it's like, why am I checking? And other times you're going to see there's a reason why it doesn't work. So let's just check these real quick. We're just going to take each of these and plug them right back into the original, okay? So if our original up here is the absolute value of x plus 1 minus 4 equals -2, I just want to plug this in. This would end up being the absolute value. Oops, let me get my pen out. If I just plug x in, this would be the absolute value of 1. Let me change colors there for you, just so you can kind of see a little better. Let's go 1 plus 1 and absolute value minus 4 should equal -2. Well, if I work that portion out, this comes out to be the absolute value of 2 minus 4 equals -2. Well, the absolute value of 2 is going to be 2, so 2 minus 4 equals -2. So this one checks out. Let's get a better check mark there. Sorry, my handwriting sometimes, woof, atrocious. But we'll get by. We'll be all right. Let's check the next portion here. X equals -3. All right, so let's check that one. Let me just block this off. That was the other side. Let's do this one now. So we have the absolute value of -3, because we're plugging in that for x, plus 1, and absolute value minus 4 should equal -2. Well, same thing if we work this out. This becomes the absolute value of -2. Once again, let me make this a little bit easier to see. The absolute value on the computer sometimes is difficult to see if I don't change the color of it. So this would come out to be -3 plus 1, which is -2, minus 4 equals -2. And this is the key thing to remember now. If I have the absolute value of -2, it's going to turn it into a +2 as the absolute value goes away. Minus 4 equals -2, which also checks out. So in this case, both of those answers stay correct. And actually in this problem, you have two answers. X can equal -1 or X can equal -3. Okay. Let's do one more real quick. Let's just talk about one more problem before we end today's lesson. All right. Let's talk about letter D. All right. You probably can already assume at this point that I wanted to throw one at you that you had to check, and we have to kind of look for something in particular. There's got to be something wrong with this, all right? That fourth step in which it tells us to check, okay, this step right here. Geez. This step right here, the check part. There's got to be a reason we're doing that. There's got to be a reason we're doing that. So in letter D, we're going to solve it out just like we would any other problem. However, we're going to kind of look at it for a second and just see, why do I got to check it? So let's go ahead and get into that. We have the absolute value of x plus 2 plus 3 equals 1. So we're going to follow our rules exactly as we're supposed to. I got to get this absolute value by itself. To do that, I'm going to subtract 3 to each side. This would give me the absolute value. The inside is going to stay the same, x plus 2. And then 1 minus 3 is going to be -2. Okay? From there, I'm going to solve it out. Okay, I'm going to actually plug this in and actually solve it out. But I want you to remember this step. So what I'm going to do is I'm going to put a little star here. I want you to remember this step, because this is going to be an important part. We're going to follow it, but we're going to come back to it later, because I want you to kind of see something within the problem. So if we follow our rules, we're going to split it up and then solve each one. We have our negative answer, so the absolute value is going to go away, and we have x plus 2 equals -2. And then we have our other answer. So all we got to do is switch it to a positive. X plus 2 equals +2. When we solve both of these out, for this one, we're going to subtract the 2 over. So we minus 2 on each side. This gives us x equals -4. Oops. Let me clean that up. Running out a little bit of room down here. Got to give myself a little bit more room. This is going to come out to be, so we're going to subtract the 2. This is going to be x equals -4. Over here, we do the same thing. We subtract 2 to each side. X equals 0. Okay? So right now, we have our two answers. But once again, this is where we have to check. And I'm going to tell you ahead of time, there's going to be a reason why we're doing it. And this is going to be the problem where you actually see the issue. So let's go ahead back up here and plug it back into the original. All right? We have x plus 2 plus 3 equals 1. So if I plug these equations back in, draw my absolute value, this is going to be -4 plus 2 plus 3 equals 1. As well as, over here, we're going to have the absolute value. Let me just block these off. We'll make a little squiggly line so we know they're separate. The absolute value of 0 plus 2 plus 3 equals 1. And hopefully at this point you're kind of seeing, I run into an issue here. So if I solve this absolute value out, this would come out to be the absolute value of -4 plus 2 is -2 plus 3 equals 1. Well, the absolute value of a negative is just going to become positive. So this is just 2 plus 3 equals 1. That doesn't make sense. So this one doesn't work. Okay, let's try the other one. Well, if I solve this out, this becomes the absolute value of 2 plus 3 equals 1. Because 0 plus 2 is just going to stay 2. Well, same thing. The absolute value of positive literally does nothing. So it's going to stay 2. And then we run into the same issue. 2 plus 3 does not equal 1. So in this problem, both of these answers, even though I worked them out, they worked, came out as wrong when I checked them. This is what we call an extraneous solution, one that doesn't actually work within the problem. Okay, this is an extraneous solution because even though I came out with an answer, it doesn't work. It doesn't work when I check it. And here's the key thing you have to understand. There's a way you can actually see this early on. The reason why I started this portion up here is because we actually run into a problem. Okay. I wondered if anyone would notice it early on, but we'll obviously talk about it right now. Right now, in this portion right here, okay, in this portion, I have the absolute value of x plus 2 equals a negative 2. But isn't that the issue? I can't have a negative 2 in this problem. I'm not allowed to. Okay? How can I ever have an absolute value, which is right here, equal a negative number? So I can actually look at this point and say, this one has no solution. Okay? And the key thing here is to look at this and say, okay, why is it no solution? Well, because I have an absolute value on the left equal to a negative number. And that is an impossible situation. That can never happen in math. It's the same thing we brought up before. If absolute value is talking about distance, that absolute value cannot equal negative 2. Okay? So there are a couple ways to solve these ones where you have no answer. You could either go through all the work like I did down here, where you check it and find out that both are not correct, or if you kind of have the savviness enough to kind of check at this point, after you get your absolute value by itself, if you check it and it is a negative number, you can automatically assume that there are no solutions to it. Okay? That is part 1 of this lesson. Go ahead and try to answer the questions, and I'll see you in class tomorrow.